We can use trigonometric identities to convert parametric equations into Cartesian equations. In this question, we have x equals 3 plus 2 sine t and y equals 5 plus 3 cos t. We've got sine and cos, so the identity we're going to be using is sine squared t plus cos squared t equals 1. So all we have to do is rearrange our x equation to make sine t the subject, rearrange our y equation to make cos t the subject, and then substitute them in to our identity. So let's start with the x equation. So we'll take 3 away from both sides, and then divide by 2. So that is sine t by itself. For our cos equation, take 5 away from both sides, and then divide by 3. So we've got cos t and sine t. Now we just substitute them in to our identity, and we have our Cartesian equation. So we have x minus 3 over 2 squared plus y minus 5 over 3 squared equals 1. That is our Cartesian equation. One for you to try. See if you can give it a go. So again, we're going to start with the identity sine squared t plus cos squared t equals 1. So sine t is x over 2. Sine t is going to be x over 2. So we substitute that in. So x over 2 squared. Cos t is y minus 1. So we substitute that in. So we've got x over 2 squared plus y minus 1 squared equals 1. That is our Cartesian equation. Find the Cartesian equations of the curve given by the parametric equations. So this time we've got x equals 2 plus tan t and y equals 3 plus sec squared t. So there is an identity connecting tan and sec. So I'll start with sine squared t plus cos squared t equals 1. Then if we divide through by cos, or cos squared t, we'll get tan squared t plus 1 equals sec squared t. So we can just substitute in for tan t. So if we rearrange our x equation, we'll get x minus 2 is tan t. So we can change tan t into x minus 2. And for sec squared t, we can say that's y take away 3. So that is our Cartesian equation. One for you to try. So we're going to be using the same identity. See if you can give it a go. So we're going to start with tan squared t plus 1 equals sec squared t. Now it's not obvious how to get tan, but remember cot is the reciprocal of tan. So for our x equation, x minus 2 is cot t. So the reciprocal is tan t. So 1 over x minus 2 is tan t. For our sec equation, y minus 3 is sec t. So we're just substituting them in. So 1 over x minus 2 squared plus 1 equals y minus 3 squared. And one more set of questions. We've got x equals sine t and y equals sine 2t. So we're going to have to use our double angle formulas. sine 2t, we can change into 2 sine t cos t. And it's all in sine and cos. We're going to be using the identity sine squared t plus cos squared t equals 1. So we can write sine t as x. So we can have x squared. For cos t is y over 2 sine t. So we'll just write that for now. Y over 2 sine t squared. That's rearranging 2 sine t cos t, dividing both sides by 2 sine t to get cos t, and that equals 1. We've still got a sine t, but sine t is x. So we can change that sine t into x. So we've got x squared plus y over 2x squared equals 1. And one for you to try. See if you can give it a go. So this time we have a cos 2t that we're going to have to change. So we can either use our cos squared t minus sine squared t, or we could use the version that's just cos, which is 2 cos squared t minus 1, or the just sine, which is 1 minus 2 sine squared t. I'm going to start with this, y equals 2 sine t, and I'll go to our identity, which is sine squared t plus cos squared t equals 1. So I can change sine t into y over 2 from this, from y equals 2 sine t. So I'm going to change sine t into y over 2. So I'll have y over 2 squared plus cos squared t. And I'm going to have cos squared t as x plus sine squared t. So cos squared t is x, I don't need to bracket, x plus sine squared t equals 1. And then again, sine t is y over 2. So I've got y over 2 squared plus x plus another y over 2 squared equals 1. So I will simplify that into 2 y over 2 squareds plus x equals 1. If we had used a different identity, so if we had gone with, instead of cos squared t minus sine squared t, we could have gone with 2 cos squared t, take away 1, and had x plus 1 over 2 equals cos squared t. Then substituted into our identity, sine squared t plus cos squared t equals 1. Sine t is y over 2, so y over 2 squared plus cos squared t, which is x plus 1 over 2 equals 1. We would have got a different version of the same answer. So if we'd multiplied by 2 and then take away 1 from both sides, we would get the same answer. So you might get a slightly different version of the same answer if you use a different identity.